Hi class, we're now covering chapters 2.7 and 2.8. This is a very short section, so I decided to join them together. Basically, we are going to be looking at problems that you will have multiple steps in a conversion problem, meaning not just one conversion, but a number of them. And if you have a multiple conversion steps, that usually means that you have to work with the numerator and the denominator in changing those units. So when you have two or more conversion factors, for instance, you will be given a quantity, and you're going to use a conversion factor to get out of this quantity into a new quantity, or unit, should I say. And now you're going to need another conversion factor to get out of this unit into this unit, which is the wanted unit. So there's going to be a couple conversion factors here. I'll show you an example, but this is normally how you do problems in chemistry. I know you may want to do one problem at a time, but trust me when I tell you that it's easier to spell it all out in one problem, and you tend to make less mistakes this way, even though it may not seem like it, and it saves time. So let's take a look at a problem here. So let me see if yes. Okay, so convert 194 centimeters to feet. So there is not a conversion factor that goes from centimeters to feet. So we're going to need to use a couple conversion factors in order to make this happen. Now, set up a map or stepping stones in order to get from what you start with to where you need to go. And in between there, put a conversion factor that's going to work to get to those stepping stones. Some of these are given to you, some of them are not. Some you would have to look up. That's why I strongly suggest you print out that under important information, that chem sheet that I give you. There's a lot of stuff in that, so it saves you time from having to look some of this stuff up. Okay, so if we start from centimeters, we can use a conversion factor of 1 inch equals 2.54 centimeters. That's exact, so we do not have to count that into our sig figs. And then we will be in inches if we set this up correctly. From there, we can go from inches to feet, and we would have another conversion factor that will not factor into our sig figs, because that is the same numbering unit, and we should end with our answer in feet. So if we set this up, looking at the stepping stone or the map, you should be able to see where these come from. So we start with 194 centimeters. We set up the conversion factor. Centimeters cancel out, leaves us with inches. Now we use our second conversion factor. The inches cancel out, and it leaves us a number, 6.3648. That's too long. It doesn't follow the sig fig rules. If you were to give this to me, it would be wrong, because you need to also follow the sig fig rules. So in this case, the only number we have to look at for the sig fig is right here in the beginning, because neither one of these is ones that we're going to look at. So it would be 3 sig figs. So if we put a line here, right here, that means that 4 is below 5. We wouldn't round up, so it's going to be 6.36 feet, 3 sig figs. Okay, so now let's look at a number where we're going to have to change a couple things. So how many minutes does it take to travel 7.5 kilometers at a speed of 65 meters per minute? So we're going to need a few conversions in order to make this happen. But the first thing, determine what you're given. You are given 7.5 kilometers, and you're also given a speed of 65 meters per minute, which I forgot to type in on number 1. You're going to need minutes, and you're going to need to know how to connect these. So you should look at what conversion factors will get you there. So the first thing we have is kilometers. Well, we know that 1 kilometer equals 1,000 meters. It's 10 to the 3, but that's actually 1,000. If you plug that into a calculator, you can see it. Now we can set up the conversion factors, and then we will figure out which conversion factor we need in order to make that work. The next thing we know is that for at a speed of every minute, you travel 65 meters. That's also another conversion factor, and we set that up based on how we think we're going to need it. So start with 75 kilometers. Kilometers needs to go. So we're going to use the conversion factor where kilometers is on the bottom, so we can cross that out. And now we have meters at the top. There's two things you need to notice here. We want to get rid of meters, and we need for this to end in minutes. So the minutes has to be at the top, and the meters, this should cross over here, needs to be at the bottom to cancel out. And we should have 120 minutes as the answer. So let's look here. This is wrong. I don't know why it says 3 sig figs. I apologize for that. This is 2 sig figs. So make a note that this is wrong here. Sometimes I don't catch everything that I should. I'm human. And here, this is exact. So it's the same numbering system. We don't need to worry about it. This is not, meters and minutes are not equivalent to each other. So this is a measured number. We don't pay attention to the 1. You look at the 65. So this is 2 sig figs. So 2 sig figs here, 2 sig figs here. That means that this is 2 sig figs, 120 minutes, because there's no decimal. So this 0 is just basically a space filler to show that this is ones, this is tens, this is hundreds, to show that this goes into the hundreds. So, because if you didn't have that there, it's only 12. So you have to put the 0 there, but it's a filler. So it's 120 minutes, 2 sig figs. Okay, some problems requiring converting units in both the numerator and the denominator. The Toyota Prius has an EPA estimated city gas mileage of 48 miles per gallon. Convert the miles per gallon to kilometers per liter. So we are going to change miles to kilometers and gallon to liter. So first thing we need to know is what information we were given. We are given 48 miles per gallon. We are going to need to make a stepping stone and know conversions in order to get this. So miles to kilometers, 1.609 kilometers per mile, that's 4 sig figs. And then we have gallons to liters. 1 gallon is equal to 3.785 liters. So if I didn't make this clear, 1.609 kilometers is equal to 1 mile. I didn't put the equalities on here, I just put the conversion factors. So you see this here. 1.609 kilometers equals a mile, and 1 gallon equals 3.785 liters. These are 2 different numbering systems, so they count. This would be a 1 right here, we wouldn't pay attention, so these 4 sig figs count in our answer, and this here counts in our answer. So now, let's go back down to 48 miles per gallon, and it doesn't matter which one you start with, but I tend to try to get rid of the top one first, and I know that I need to end in other units. So when I write out a problem, I write this number out here, I leave a bunch of space blank, I put an equal sign, I leave space, and then I write the units it needs to end in, so that it will help me keep track that after I do the calculation, does it match. So basically I would write this out, leave this blank, and then this isn't here, and leave this, kilometers per liter. That will tell me that's what my answer has to be in. So when you see miles per gallon, that means one is over the other. Kilometers per liter, miles per gallon. They go together. So 48.0 miles per gallon. So in this case, they have it set up to get rid of miles. So 1 mile equals 1.609 kilometers. The miles cancel out. Kilometer stays on top. We want our answer in kilometers, so we're actually done here. Next thing we're going to start with is liters. So gallon is at the bottom, which means that if it's at the bottom, it has to be a top in the calculation to cancel out. So we're going to take 1 gallon and set it on top, and 3.785 liters at the bottom. Why at the bottom? Because liters needs to be in the denominator. And then the gallons cancel out, and if you see, we have kilometers here, and we have liters. That spells out kilometers per liter. We have 3 sig figs, 4 sig figs, 4 sig figs, 3 sig figs wins. So 20.4 kilometers per liter, 3 sig figs. That's our answer. And we've managed to go from miles to kilometers and gallons to liters. And that's it.